And so here's some problem-solving tips for freefall problems. The first one is that if it actually is in freefall, that is, if there's no air friction acting on the object and it's close to the surface of the Earth, right? If the force of gravity is the only force acting on it, then the acceleration is negative 9.80 meters per second, okay? That's if it's freely falling. It even still has that acceleration at the top, okay? And we'll talk about that. We'll graphically look at that, right? And then the final one is that the velocity at the top is 0, okay? Oh, wait, I'm not sure my pen is the right color here. Oh, it's red. We'll go with the red pen, right? So what I'm saying here is that we're eventually going to do this lab where we shoot these rockets up, right? The rocket's going to go up, right? And it's going to go down, okay? At the top, that final velocity is 0. And the reason for that is if it's not 0, it's not at the top, is it? Okay, it's on its way up or it's on its way down. Okay, so yeah, and at that moment, right, it's got 0 velocity, but it still has this downward acceleration. And I'll show you how to visualize that. Okay, so velocity at the top is 0. This is key. Okay, and then if it starts and stops and at the same elevation, just like the rocket lab, or if we pop a baseball up straight up and it gets caught at the same level as the bat, right? There's 2 more things that are true, right? And I'll explain this, okay? We spend half the time up and half the time down. So for example, if it takes 3 seconds to reach the top, it'll take 3 seconds to get to the ground, right? And so it's in the air for 6 seconds, right? So if you figure out the time to the top, you can just take that and go 3.0 times 2 and get 6 seconds, right? Or if I tell you it's in the air for a total of 8.86 seconds, right? If it goes up and down in 8.86 seconds, if that's the total time, okay, then you know that it spends 4.43 seconds going up. And it also spends 4.43 seconds going down, right? Okay, so these are the important tips, right? So if I give you a total time in the air, you can cut it in half, right? You can go x, vi, vf, a, and t, right? The time is going to be half the time. So in this case, you could say 4.43 seconds. Final velocity is 0. Acceleration is negative 9.80, right? 4.43 in this case, right? If I tell you this. And it looks like I've told you nothing, but I've really told you 3 things. In half the time, right, it's going to be at the top, and the velocity will be 0, and the acceleration all the way up was negative 9.80. And if you know anything about these, right, you know that I've given you enough information to solve the whole thing, right? And then the final thing is that the final velocity is negative the initial velocity. We're not going to use this very often, but for example, if this is positive 29.4 meters per second, it's going to hit the ground going at negative 29.4. Now this is, of course, if there's no air friction, okay? If there is air friction, it'll hit the ground going slower than that because it will have lost energy, right? But we're not going to look at air friction for these problems, okay? But I do have some demonstrations about air friction that, of course, I'll do for you guys. Let's take a look at a graph, okay? Let's take a look. I'm going to go back to blue pen color here. Let's go blue, okay? If we look at a velocity versus time graph for a rocket going up and then landing back on the ground, the graph looks like this, okay? So this is positive 29.4, leaves the ground, right? When it reaches the top, it's right there, right? And then when it strikes the ground again, here it's negative 29.4 meters per second. Now, this is a velocity versus time graph, right? Here's 0 meters per second. That's how I know it's at the top, right? This is leaving the ground, right? And then this is striking the ground again, right? Notice that the slope of this line is unbroken. The slope is negative 9.80 meters per second every second, right? Okay, so the slope is unbroken, but there is a point where its value is 0, okay? So I don't know, just think about that, right? It's possible to have an acceleration but have 0 velocity, and that's all I'm saying.